dealing with two population parameters. We will be dealing with the population mean for the most part. Which is mu. And we will also be dealing with the population standard deviation, which is sigma. So we'll be dealing with those two. We're not going to deal with the population proportion. We'll just be dealing with these two. Mostly we'll be dealing with just the mean. But you will still be using that t-table. So that t-table we dealt with the last, and chi-square table with last part, we will still be dealing with that. When you deal with hypothesis testing, once again, this is a decision-making process for evaluating claims about a population. We make decisions based on this. Business corporations, they make decisions based on this. I don't know if you think, look at news or financial world or anything of that sort, but another bank went under last weekend. J.P. Morgan, which is a financial institution, decided to buy this bank and all the assets that goes with this. They made a decision that they can turn this into a profit for them. They're not going to make this decision where it's going to lose them money. They'll be at least able to stay even and make some money off of this. Statistical hypothesis. It's a conjecture about a population parameter. This conjecture may or may not be true. As you grow up through life, and as I've realized in life, you should become dart throwers. Okay? About ideas. You throw darts. Some of them will stick to the wall, some of them will fall to the floor. But the ones that stick, those are good. Ones that fall to the floor, okay, that wasn't maybe a good idea. Okay, I gave you an idea, something to think about. We thought about this, it didn't work out. That's okay. So when you throw darts, some of them stick on the wall and on the dartboard. Some of them hit the dartboard and fall down the floor. And that's okay. As you go through life, that's what will happen. Some of your darts will stick, some of you won't. Some of the darts won't. And you have to learn as you get older, as you work in a business or go into the business world or corporation world, that's what people want in their businesses. People don't want just yes men or yes women to say, oh yeah, that's what we should do. Yes, we'll do exactly what you say. We'll do exactly. They want people to sit there and say, okay, give me some ideas. Here's some ideas. I've thought through them. It may be good, may not be good. It's okay. But at least we have ideas, something to think about. Okay? And that's how life is in regards to darts. You throw darts. Some of them stick, some of them don't. And you don't take offense on the ones that don't stick. You don't get mad at that dart that fell on the floor. Oh, I lost the dart game. Oh, well. I lost the dart game because that one didn't stick over there. Oh, well. I'm going to pick my darts up. I'm going to have another game at it. Hypothesis. Once again, we talked about hypothesis as an educated guess. It's an accepted value for the population parameter. Most of the time. When you have an accepted value to a population parameter, that's most of the time your hypothesis. And most of the time what you're trying to do is either prove or disprove, either say, okay, yes, I'm going to agree with that. Here's my statistical analysis that agrees with this, or I'm going to say, no, it isn't working. Sir Fig of Isaac Newton, 9.81 meters per second squared. Okay? I want to disprove that. Okay? That's an accepted value, 9.81 meters per second squared. The null hypothesis. Okay, we have two different types of hypotheses. We have the null hypothesis, which is a statistical hypothesis that states that there is no difference between a parameter and a specific value. Or that there's no difference between the two different parameters. We'll test just one value, and then we'll make a comparison. As we go through this, we'll compare two statistical means. Example, we'll use two statistical values. Is there a difference in the high school between male and female average ACT scores? Is there a difference? Or are they pretty much the same? They might not be exactly the same, but with respect to a little bit of an error, are they pretty much the same? The average income in a house, or average income in a household in Downton Local School District compared to Orville School District. Is there a difference? Is one greater than the other? We can make a comparison about that. The null hypothesis is basically an accepted value that's already we want to test. We want to test an accepted value, 9.81 meters per second squared. We want to test that. Most of the time there's an accepted value there. Not all the time. We'll go through a couple examples where it's not there. But most of the time it's going to be already an accepted value, and we want to disprove that. Okay? Think of the show Mythbusters. The show Mythbusters. Okay? The Mythbusters, they try to debunk and they try to disprove all these things or prove all these things with Mythbusters. And they run experiments with respect to things that are going on. And they set parameters in regards to that, and then they run these experiments. They either prove or disprove. So like Mythbusters is very similar to what hypothesis testing is. The second hypothesis is called an alternate hypothesis. Now, it's H1 or I tend to put HA there. It depends on which book you look at. Some of the books will have HA, some of the books will have H1. The statistical hypothesis states that there exists a difference between a parameter and a specific value, or there is a difference between the parameters. So it's basically the same thing, except for the word no difference is now just a difference. Mythbusters is pretty cool. If you ever watch it, if you ever watch Mythbusters and you like some of that scientific ideas or some of the things that people accept, and Mythbusters is sort of a cool show to watch. The alternate hypothesis, once again, it can be H1 or HA. Most of the time, what we can state with respect to what an alternate hypothesis is, in our mind, to put it simple in our mind, is what we hope is true. It's what we hope is true. Okay? There's an accepted value there. We don't quite believe this accepted value. So this is what I hope is true over here. And that's your alternate hypothesis. in hypothesis testing, we gather evidence against the hypothesis. We look at the probability of observing an outcome, our probabilities. And that probability goes back to our Z table and our T table. Okay, because our Z table gave us area. Area gave us probability. So there's a lot of connection to the tables and what we're dealing with here. And we will utilize that. If the probability is significantly small, that leads us to doubt the initial claim, that null hypothesis. I remember initially going through hypothesis testing. I remember barely back in college doing it, but then I had to take graduate level class, and I had to take statistics in there, and I was teaching it. I wasn't teaching it yet. But we went through hypothesis testing in the class, and the gentleman that was teaching it made it to be this humongous conglomerate of information that you had to provide to be able to go through hypothesis testing. And he made it so difficult. It's like, oh my gosh, this is tough. And then when I started teaching it, I started to simplify things down and relate it to what we dealt with. Hypothesis testing is not very difficult to deal with. Okay? It is basically utilizing calculations of a Z-score and looking at a Z table or a T table and making a decision and looking at a bell-shaped curve. It's not as difficult as they made. So this is probably the same as what you had with respect to confidence intervals. You have one additional step here. Okay? In each one of the problems that you're going to have to read the problem, and you're going to have to state initially a null and an alternate hypothesis. Okay? You'll have to state these. Now, the process that you have to state this is, my suggestion to you is you start out with the alternate hypothesis. Because the alternate hypothesis is something that we want to be true. This is what we are hoping to be true. So we start out with the alternate hypothesis. And the null and alternate hypothesis is always, for this first part, always going to be dealing with our population mean. We're going to make some statement about the population mean. Also, the thing to remember is some form of equality will go with the null hypothesis. Some sort of form, and we'll talk about that here in a second. We'll go with the alternate or the null hypothesis. And once again, the first step is to write out the null and alternate hypothesis. It's going to be some comparison to, in the first part, to the mean, and when we eventually get into this, it will have something to do with standard deviation or variance, but we'll just deal with the mean right now. A researcher thinks that if expected mothers use vitamin pills, the birth weight of babies will increase, the average birth weight of, will increase. The average birth weight of the population is 8.6 pounds. So what you have here is you have a researcher. Okay, you have an established value of 8.6 pounds. The researcher says if they take these vitamin pills right here, expectant mothers take these vitamin pills, the birth weight of the child will increase. Now, when you're talking about birth weights of children, the more birth weights that you have with the child, the healthier they feel the child will be. If a child is born is only 2 pounds or 1.5 pounds, not very heavy, that baby is going to go into a neonatal unit until the birth weight increases. The birth weight is 6, 7, 8, 9, 10 pounds. I'm forbid a 10 pounder. I was a 10 pounder. So, but the healthier the baby's going to be. Okay? So, what this researcher says, they've developed this vitamin. And the hope for him, this researcher says, if they take these vitamin pills, birth weight's going to increase. Translation, birth weight increases, baby becomes healthier. And that's what they want. Or mom. So we start out with the alternate hypothesis. What does the researcher hope is true? Well, he hopes that the birth weight increases from 8.6 pounds. Well, if I talk about mathematics ideas, we could talk about increasing, decreasing, being the same as less than, greater than, or equal to. Well, what is he hoping is going to be true with respect to the birth weight? What does he hope the population mean is going to do? Go up, which means it's going to be greater than 8.6 pounds. That's what he hopes is true. That's what we want with the alternate hypothesis. What do we hope is true? We hope that the baby's weight's going to increase. So at that point, we can now gather data and do a statistical analysis on that. We could do research. We could do, okay, this set of people are given these pills. Let's take a look at the birth weight of the children at that point. What's the birth weight? Is it going to be greater than 8.6 pounds? Or what's going to happen? What's the mean going to be? The null hypothesis is the SpongeBob opposite day of the alternate hypothesis. That says it's greater than, which means this will be what? Less than or equal to.
It's like everything else.
Less than or equal to 8.6 pounds. Okay, we always include equality with the null hypothesis. An engineer hypothesizes that the mean number of defects can be decreased if a decrease in manufacturing process of CDs, old school, by using robots instead of humans. That shows you how old this is. For certain tasks. The mean defects of DES is 18 per 1,000. Engineer says, well, if I use a robot rather than using human, that's going to eliminate human error. Okay? The number of defects is going to decrease. So we go to the alternate hypothesis first. What would be the alternate hypothesis? Why would they? Mu is going to be what? There we go. It's going to be less than 18 per 1,000. Which means the null hypothesis would be the opposite to that. Which would be what then, Nick? What's opposite to less than?
Greater than.
Or equal to. Greater than or equal to. 18 per 1,000.
Oh dear.
A psychologist feels that playing soft music during a test will change the results of the test. I'm going to put some Bach and Beethoven in here, some sleepy elevator music. He is not sure if it's going to raise or lower the test scores. In the past, the mean score is a 73. So we're looking once again for mu, population mean. Now, how do we deal with this? Not sure if it's going to be greater than or less than. It's not going to increase or decrease. He just says it's going to change. What do you think we should do with the alternate hypothesis here then?
Not equal?
Not equal to. It's just going to be not equal to. I'm not sure which direction it's going to go. Some people may be repulsed by listening to Bach and Beethoven during a test and are so fixated on that music there that they can't concentrate on their text. So that it lowers it. Other people may say, that's a calming thing. That's I feel so much better. It makes me focus a little bit more. Well, what's the SpongeBob opposite to this? What's your norm? Equal to. I didn't give you a number on this one. Let's go down to the chemists. Okay, next two. Chemist invents an additive to increase the life of a car battery. The mean life of car battery is without the additive is 36 months. Okay, he has some additive that he put into the car battery. And the last one, a contractor wishes to lower the heating bills by using a special type of insulation in a house. The average monthly bill is $78. Okay, write your null and alternate hypothesis for the last two. Compare your answers with somebody around you then.
Short opposites of each other.
Once again, think of the alternate hypothesis. What does the person want to be true? Okay, you always start with the alternate hypothesis. What do they hope is true? Okay, so you always start with the alternate hypothesis. What do they hope is true? So you have to read the problem and figure out what's he hoping for. That's the alternate hypothesis. Adam, what do you have for the first one? What do you have for the alternate in the first one?
Greater than.
Okay, greater than 36. Because what he wants is true. If I add this additive into it, it's going to increase the life of the car battery. So people are going to want to buy that because I don't want to have to buy a car battery every 3 months because those things cause some duckies out of my pocket. Okay, if I can go 4 years or 5 years with a car battery, okay, that's better. I don't have to buy as much because we all know the world has turned into a recyclable world of if we can get things to last more than 3 or 4 years, we're happy about that. Before, they used to build things that lasted a long time, 10 years, 15 years. Well, that's not profitable for businesses because they're not selling more and more things, okay, because people aren't buying as many things. Okay, so we've turned into that. So if I can increase my life, which means my null hypothesis here, that would be what, Amara? Less than or 36. And once again, if you want to put months in there, that is fine. Contractor wishes to lower the heating bills by using special type of insulation. Okay, the average monthly bill was $78. Grayson, what would be our alternate hypothesis here?
Mean is less than 70,
Which means the null then would be what?
greater than.
Okay. So stating the null and alternate hypothesis is the initial part to all of our problems here. Okay, what I'm going to give you here is a worksheet. Now this worksheet is going to be your homework for the next 2 days after this. We will continue to build on this. The only thing I want you to worry about today is being able to write a null and alternate hypothesis. So I need you to read the problem, find what that accepted value is. Okay. Now, when you're doing this, don't write the null and alternate hypothesis right here in the middle, because you're going to be doing work on this problem as you go throughout. So just up here along the top here, just along the top by the problem, what is your null hypothesis? What is your alternate hypothesis? And once again, we're dealing with mu here. Okay, so just right along the top here, you read the problem, write your null and alternate hypothesis, and that's all you got to do for today. Tomorrow we'll come in, we'll start doing some mathematical computations with them. Okay, and we'll continue to work with these problems here. But you need to start first off just with the null and alternate hypothesis. All right, questions? Let's get it. This will be your worksheet for the next couple days here, so just make sure you keep them.